Hello everyone, my name is Logan Sheehan and welcome back to the lecture hall. Today we're going to be covering section 3.1, derivatives of polynomials and exponential functions. So we're going to start off with constants. What's the derivative of a constant? And the constant is just a number. Right here we have f of x is equal to c. The c is any number. Don't get tripped up on the c. Just realize that it's not x. It's not your input variable, so it's just a constant. It's just a number. So the derivative of f of x is equal to 0. Well, how do we know that? Well, let's just plug it into the formula for the derivative. So f prime of x is equal to the limit of f of x plus h minus f of x all over h. We know this. It's pretty simple. We've gone over it a lot. And then, so now that comes down, limit of h, as h approaches 0, of c minus c over h, which is equal to, because c minus c is 0, so it's equal to the limit of 0 as h approaches 0, which is equal to 0. So we can see that constants, so the derivative of constant c is equal to 0. So now onto the derivative of x. If you have y equals x, the slope is obviously a line because it's 1. So we have the graph of y equals x, and we know, okay, it has a constant slope. So from that, we know, okay, derivatives find slopes, and every single part in this graph, it runs once, right? Goes up over 1. So from that, we know the derivative is equal to 1. Well, how can we just say that? Well, we can plug it into this function and find it. Or what we can do is we have this brand new thing called the power rule, and it simplifies polynomial derivatives immensely. So, what is the power rule? Alright, the power rule states that the derivative dx of x to the n is equal to n x to the n minus 1. So if we go back to what we had, y equals x, or f of x is equal to x, well, how do you take the derivative of this? Dx of f of x is equal to, so we know f of x is equal to x to the 1, right? So we know 1 comes over, right? You bring it in front, and then you do 1 minus 1. So then you get 1 x to the 0, because 1 minus 1 is 0, and the 1 comes in the front. So you get 1, f of x, the derivative of f of x is equal to 1, x to the 0, and then x to the 0 is equal to 1, so you just have it's equal to 1. So now let's do it with a harder one, because that's very simple. So let's do f of x is equal to x cubed. So let's start with the limit definition, and then we'll do the power rule to show the difference, to show that the power rule is a lot better. So you have x plus h cubed, on the outside of the parentheses, minus minus x cubed, and then you get over h, and then that is equal to, I'm just going to do the simplified form. You can work it out on your own. X cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed. Those cancel out, right? And this is all over h. And then you can factor out an h from all of these. H, 3x squared plus 3x h plus h squared all over h, right? And you cancel those out, and then you just have, I'll write that back, limit as h approaches 0 of 3x squared plus 3xh plus h squared, and then that, because, we canceled out the h's, and then as h approaches 0, well, you can just plug it in. There's no denominator. You can just plug in the 0. You just get 3x squared. So, it isn't that hard, but it did take quite a bit of the board, and it almost took me a minute to do it, the whole thing. So let's do the power rule version. Power rule. X to the n d dx is equal to n x to the n minus 1. So we have x cubed, where n is equal to 3. So then you set that equal, you make sure you write d dx so people know that you're taking the derivative. Notation's important. So 3 comes in front, so you have x, 3 minus 1, and the 3 comes in front, right? So 3 comes in front and it's subtracting 1, so you get is equal to 3x 3 minus 1, which is 3x squared. So as you can see, wow, that's a lot quicker. This took 2 lines. I didn't even have to write this line out. And I really could have just gone from here to here. It's really quite simple, but I wanted to show you guys so you could truly see it. But this is a much, much easier way to do polynomial equations. Alright, so now let's just do a few quick examples. What is d dx of x to the 4th? What is that equal to? Well, you bring the 4 out in front, so you write 4 automatically, and then x, because that's what comes next, and then 4 minus 1 is 3. Okay, that's pretty simple. Let's do one more. D dx of x to the 5th. Well, that's equal to 5, x to the front, x, and then 5 minus 1, 4. Okay, alright, now last one, not last one for the whole video, we're going to do quite a few of these, but here's another example. So we have dx of 5x squared. Well, what can, okay, there's a 5 in front. Does that, cause any problems? Not really. You can just put it in front. You can just take the 5, put it here essentially, cross it, 5 there, and then you just do the power rule on x squared, so that's 2, and then x, 2 minus 1 is 1, so it's just x, and then you just multiply the 5 back, and so it's 10x. So from that, we get an identity that states that dx of c times f of x is equal to c times dx of f of x. Alright, so that's pretty simple. That makes it a lot easier. We don't really have to deal with constants. Okay, now we go on to the sum and difference rules. For both of these, f of x and g of x have to be differentiable functions. And they state that d dx, which is taking the derivatives, sometimes you'll see f prime of x means the derivative that is equal to d dx of f of x. But for this case, it's easier to write d dx. So d dx of f of x plus g of x is equal to d dx of f of x plus d dx of g of x, right? And so now onto the difference rule, and it's actually combining the sum rule and the constant rule. And I'll show you how in a sec, because it doesn't really look like it, but it does. So d dx of f of x minus g of x is equal to d dx of f of x minus d dx of g of x. And that is equal to saying that the derivative of f of x plus negative 1 times g of x, right? So we have d dx f of x plus negative 1 times d dx of g of x. And that gives us our difference rule, because your c in this is equal to negative 1. And that's how you get the difference rule. So, now on to exponential functions, and let's start with the exponential part, the e. What is e? E is Euler's constant, and e is a number such that the limit as h approaches 0 of e to the h minus 1 over h is equal to 1. I didn't write it down, it's not that important, you don't have to know it. But if you look at it geometrically, if you look at the graph of e to the x, something like that, an exponential growth curve, e to the x has a tangent line at 0, 1, where the slope is equal to 1. So 0, that's 1, this is 0 on the x, and that's 1 on the y, and this has a tangent line of slope equal to 1. So that's also why it's important. So now let's go on to the derivative of the natural exponential function. D dx of e to the x is equal to, any guesses? E to the x. What? Just e to the x? What about the power rule? Well, it doesn't apply because this is e to the x, not x to the e or something like that. And so this makes sense because the derivative of exponential functions are like with base not e, right? Or well, and base e, so d dx of b to the x, any constant, is equal to b to the x times ln of b. And ln of e is equal to 1. So the derivative d dx of e to the x is equal to e to the x times ln of e, which is equal to 1, so that's equal to e to the x. And we're going to go into more in depth on why these work. It's called chain rule. If you're interested, look it up. It's not too bad. I'll have a video coming out pretty soon on it. But yeah, so that's the derivative of e to the x. Just remember, e to the x is really easy. If you see it on a test, don't get freaked out. Just put e to the x. But if you had something like dx of 3e to the x, that is equal to 3e to the x. Just remember to bring the constant out, and do the derivative and then multiply the constant back in, and you have it. Alright, that's all for the lecture portion of the video. There will be suggested homework in the description. Yeah, let's transition to some practice questions. Alright, now onto the practice questions for this section. Today we're going to be doing 3, 4, 7, 13, and 16. We're doing so many because these are quick, and you should really get into the habit of being able to just, if someone says, what's the derivative of x squared, you just know 2x. Power rule is really quick. On the test, there are going to be a few point questions that you either know the power rule, get it right, get the 3 free points, or you get it wrong and it starts to tank your grade. So I just remember the power rule. It's very, very important for this class. Alright, so let's start with number 3. 2 to the 40. What do we do? Ln something, ln of 2 times what is it? Well, first you need to look at the function. What is it saying? It's saying 2 to the 40. It's saying 2, a number, to the 40th power to another number. So a number to a number is another number. So it's just a constant. Yes, it's 2 to the 40, but 2 to the 40 is just a number. So it's just a constant. So the derivative of 2 to the 40 is just 0. If you remember that from earlier on, any constant is 0. The derivative of any constant is 0. So now, on to number 4. Well, e to the 5, isn't that just equal to e to the 5? Well, what is e to the 5? E to the 5, e is a number, 2.718. That's all I know. I don't even know if that's correct. But it's just a number a little bit less than 3. So then e to the 5, same sort of thing as 3 over here, is just a number. So then d dx of e to the 5 is equal to 0. Okay, these were like trivial examples just to show you that numbers, even though it doesn't just have to be a singular constant, it can be a constant to another number or something. Yeah, so now let's actually use the power rule. So we have 2t cubed minus 3t squared minus 4t. So remember, from the difference rule, you can do each term one at a time. So let's start with 2t cubed. So we have 2 times 3t, because you bring the 3 in front, and then minus 1 squared, which is 6t squared. And then you have minus, so that's, and then you have 3 times 2, This 2 comes in front, and then minus 1, 2t, minus 1, 2 minus 1 is 1, which is minus 6t. And then you have minus 4 times t, and that's still 1. Bring the 1 in front, 1. Minus 1 is 0, which is 1. So then you have minus 4. So the answer is equal to 6t squared minus 6t minus 4. Alright, not too bad. So, 5 over r cubed. Wait, over r cubed? Well, it's clearly a power function, but what is it? Like, how can we even use power rule? Yes, of course you can. Because you just need to think what is, as I said, for these, you just need to look at the function. What is the function? That function, 5 over r cubed, is equal to saying 5r to the negative 3. Because 1 over x is equal to x to the negative 1. Whenever you have a power on the denominator, it just becomes a negative. So, you know that now. So you have 5r to the negative 3. Well, negative 3, can you still do power rule? Yes, of course you can. So then you just bring the 5 out in front, right? And then you bring the negative 3 in front. You do not forget the negative sign. So then you have negative 3, r, and then you have negative 3 minus 1. What's negative 3 minus 1? Negative 3 minus 1 is equal to negative 4. So then you have r to the negative 4. So then, the answer to this is equal to negative 15 r to the negative 4, which is equal to saying negative 15 over r to the 4. Right? That's pretty simple. Alright, so now on to 16. This one, again, looks tricky, but it's not. I'm just erasing 13 because I need more space. So, again, well, that's not totally a power. I mean, there's a 4 here, but I don't necessarily see any powers. Well, it's to the 4th root, but again, just look at it. What is this saying? The 4th root of t, that's equal to saying t to the 1/4. When you have a square root, so you have the general form n of t is equal to t to the 1 over n, and then if you have n t to the m, that is equal to t to the m over n. Right? So you just need to remember this. You probably learned it in algebra. Maybe you remember, maybe you don't. That's why I went over it. So there's this. Now you have to take power rule of this and then minus 4e e to the t. So let's do that. So you bring out the 1/4, right? And then you subtract 1 from it. So then you get 1/4 t. You get 1/4 t, and then what's 1/4 minus 1? Well, it's just going to be 3/4, right? Negative. So it's 1/4 t to the negative 3/4. And then you have minus 4e to the t. So you have minus 4, right? You can just put that out in front. It's a constant. You don't really have to worry about it. Then you have minus 4e to the t. Well, what's e to the t? E to the t. The derivative of e to the t is e to the t. So then you get e to the t. So you have your answer. The answer is 1/4 t to the negative 3/4 minus 4e to the t. So that is all for the video today. My name was Logan. Thanks for watching.